Welcome to another exercise for the workbook statistics. This time I'm going to focus on the covariance and correlations, or rather on measures of association. Our exercise here: for 5 visitors of an amusement park, the time spent in the park in hours, as well as their age, is summarized in the following table. And we have here the 2 variables and 5 observations, and what we should do is simply calculate the covariance. Well, let's get to it. So I'm going to copy the table as is, and then I'm going to add one additional row. Just named all the variables x and y, but for the variance, but also for the correlation coefficient, this could be assigned arbitrarily. So it doesn't matter what is x, what is y in this case. And well, in this row, I'm simply going to multiply those two. So 2 times 32, 10 times 23, 12 times 32, and so forth. That's actually all the rows I need. And then I need one additional column, or rather here I'm going to first off sum up all the values. Then I'm going to divide them by the number of observations. So I'm going to calculate averages for x, for y, and for x times y. Giving me here for x 7.8, for y 28.6, and for x times y 214.2. That's actually the only 3 values I need, because if I take a look at the formula for the covariance, that's actually here average of x times y, that's 214.2, minus average of x, that's a 7.8, times average of y, that's the 28.6. So I'm going to put in all these 3 values, and I get as an end result minus 8.88. Well, I definitely see this as a negative relation. So younger people spend more time in the park, but I'm not really so sure what the 8.88 means regarding the strength of the relation, because the covariance can be anything between minus and plus infinity. So the question is 8.88 large or small? That's actually a big problem. That's if you talk about the size, the strength of a relation, you're no longer looking at the covariance. You're usually using the correlation coefficient, where we're going to divide the covariance also by the standard deviation of x and y, limiting it to a range of -1 to +1, allowing us then to better, well, tell which is a strong, which is a weak relation we measure. So this just tells us it's a negative relation. Well, that was already everything there is to this exercise. So I hope you enjoyed it. I say goodbye and see you next time.